So hey there, in last video we have came across the number system. We learnt about the binary number system, the octal and the hexadecimal. We also studied that how to convert one number system into the other and the vice versa. In this very lecture we will focus on processor. What is a processor of a computer system? Processor means CPU. Okay, make a note of this thing. Whenever you face the word CPU, that means processor. Okay, so in this very topic I will teach you and we will learn about the structure and functioning of the CPU, that is a processor. Now what is CPU? As I have already told you in the last lecture, the CPU is a brain of a computer system. We already know it. It performs all major calculations, comparisons, and also activities, and controls the operation of the other units of the computer system. We know that. Hence, no other single component of the computer determines its overall performance as much as it is CPU. So, in order to evaluate a computer's capability quickly, it is important to know how CPUs are internally structured, how different CPUs differ from each other, and how to evaluate CPU speed. Okay, I will make a design over here. I will try to make the design of a processor over here. This is the basic design of a CPU. It's very pathetic, sorry for my drawing, but I will try to describe what each and every part here is. So look, this whole cabinet, this whole very portion is known as CPU. Alright, so CPU consists of the main memory over here, which is RAM, which we will going to talk later. There is a other type of memory which is known as a cache memory, so we will talk on it later again. Then we will face two different parts of a CPU, which are the major parts of the CPU, and collectively control unit and arithmetic and logic unit combines to make a CPU. Okay, so in control unit we have a lot of registers. These are the registers which have the functionality, different functionality to process the data. All right, and ALU has other registers as well, which have different functionalities of just calculating that data. All right, so I will first of all tell you what control unit. We have already read it, so we have already saw these basic two components of CPU, which are the control unit and the arithmetic and logical unit. Although the control unit does not perform any actual processing of data, it acts as a central nervous system, as I have already told you in the previous lecture, for all the other components of the computer. It manages and coordinates the entire computer system, including its input, output units. Okay, it obtains instruction from program stored in the main memory. Okay, this main memory, and interprets the instruction, issues the signal that causes other unit of the system to execute them. So it was the functionality of control unit. Now look, we have already talked about the ALU also. So arithmetic and logic unit of the CPU is a place. It is that place where actual execution of instructions take place. So during data processing, actual execution of those instructions are taking place. So when the this control unit encounters any instruction that involves an arithmetic operation, such as addition is there, subtraction is there, multiplication, division, or any logical comparison such as less than, equal to, greater than, it passes it this control unit passes control to arithmetic and logic unit, and this is the functionality of arithmetic and logic unit, what it does. So this was the basic explanation of control unit and arithmetic and logic unit. So I will tell you what registers are. First of all, these are all the registers. So what are these registers? As a computer CPU, this CPU interrupts and executes instructions. There is a movement of information between various units of a computer, So to handle this process satisfactorily and to speed up rate of information transfer, okay, the CPU uses number of special memory units called these registers. Okay, these registers hold information temporarily and are part of this CPU. These are the part of this CPU. They are not the part, these acts as a memory, but they are not part of a memory. Okay, they are the part of the CPU only, the processor. So we can how we can distinguish between them. Length of register is equal to the number of bits it can store. Okay, so hence we refer to a register that can store 8 bits as an 8-bit register. Alright, most CPUs sold today have 32 bits or 64-bit register. You have heard it, I'm sure about that. The length of the registers of a computer is sometimes called a word size. We also call it a word size. The bigger the word size, the faster a computer can process a set of data. With all other parameters being same, the CPU with 32-bit register can process data twice as large as one with 16-bit register. So we will see about now, since we know now about the what are registers, now we will see what are these registers, how they got these names, and what are their specific functionalities. So first of all, let's take this memory address register. As I have told you, what memory address register does, it holds address of active memory location. Okay, this is the memory location over here, and the active memory location where the work is being done. This active memory location is stored in this memory address register. This register is just a simple set of memory which holds few bits, so it holds the current memory address. So this was the functionality of memory address register. Now let's see the memory buffer register. This is the memory buffer register. So it holds the information on its way to and from the memory. That means it holds the information of the memory chunk which is going from the memory to the processor or from the processor to the memory. It holds the address of that particular memory location. All right, now we have other like program. This is program counter register, program control register. So what does it do? It actually holds address of the next instruction to be executed. That means, look, right now this memory address is being executed in the control unit, or in, we can say in general, in CPU. This processor is executing this memory location right now, but the next instruction which is going to be execute after that, this program counter register is holding the address of that very, because it's in the next, it's going to be executed and it is going to pass to the processor. All right, now we have next, we can say the this IO register, which is input output register. What it does, it just simply communicates with input output devices. So I have already mentioned it over here, that input output devices are also linked with the CPU with the interface. Okay, I have already told you this in your previous lecture. And secondary storage devices are also connected to the CPU with the help of these interfaces. All right. So next is instruction register. So what does this instruction register do? It holds an instruction while it's being executed. Look, right now this memory chunk, it's holding, it's executing, it's being executed in the CPU right now, but maybe meanwhile the CPU has to make some data and have to keep it on hold for a while. This instruction register is responsible for that. So what it does, it holds that instruction while it is being executed. Okay. All right. And this decoder actually helps in decoding the data to and fro from the memory to the processor. All right. Now here is one more register in case of ALU. This is called accumulator register. Okay, this accumulator register, it accumulates a result and data to be operated upon. Look, the arithmetic and logic unit, for example, it's adding 2 plus 3 right now, because this is the arithmetic and logic unit. So the arithmetic operation is the task of it. So accumulator, what it does, it simply holds these, result and the data. It holds this 2, it holds this 3, and it holds this operand also. So that can be merged later. The holding of these data, it is the task of the accumulator register. By its name, it explains itself that it accumulates them. Okay. And those are GPR, means general purpose registers, and they have different functionalities. Look, apart from these specific registers, you might need some other data to be kept somewhere for a while. So these general purpose registers are being used in those cases. Okay. Look, CPUs, now CPUs are of different types, as we have already came across with them. We know that CPUs are of very different types. So how can we distinguish between different CPUs? There is a concept, there is a thing which we call as instruction set. Okay, I will write it down over here. Instruction set. What is the instruction set? Look, I will explain it. Every CPU has a built-in ability. It's a built-in ability. Make a note of this thing. It's a built-in ability. So built-in ability to execute a set of machine instructions called its instruction set. Okay, most CPUs have 200 or more instructions, such as we have instruction already given, such as addition is there, subtraction is there. So these are pre-coded instructions already stored in the instruction set and making a whole set and already being loaded to the CPU at the time of manufacturing. Okay, so these instruction sets are usually 200 or more than 200 instruction sets. So the list of instructions supported by the CPU in its instruction set forms the basis for designing the machine language for the CPU. It forms the basis of it. So since each processor has a unique instruction set, machine language programs written for one computer will generally not run on another computer with a different CPU. So I hope you have understood the instruction set, what is instruction set. So next concept I will give you over here is a processor speed. Look, CPU knows how to calculate data, how to play with the data, but it has to do it in a minimum time as it can. So the processor speeds plays a very important role. So The speed at which a computer executes an instruction directly depends on the computer's built-in clock speed. Okay, this clock speed, which is the number of pulses produced per second. Okay, remember this point, number of pulses per produced per second. We measure clock speed in usually in megahertz or in gigahertz. Okay, where we know that the megahertz are 10 raised power 6 and gigahertz are 10 raised power 9 hertz. Okay, and these are being done just in just a 1 second. So 10 raised to power 6 cycles per second. Okay, same is the case in here. Okay, normally we measure the processing speed of a personal computers in megahertz and gigahertz, of a personal computers. But for a workstation, mini computers and mainframe computers, we measure them in MIPS. We call it MIPS. Okay, MIPS means million of instructions per million of instructions per second. Okay, or we can say bips, billion of instructions per second, billion of instructions per second. So those were for the mainframe and workstations. So if we talk about the supercomputers now, those were for the personal computers, like normal personal computers. Those were for the workstations and mainframes. Okay, but for supercomputers the thing is little different, because for supercomputers the measuring unit is, sorry, I am not able to, yeah, mflops. Okay, mflops, what does that mean? Those are called millions of floating point, millions of floating point operations per second. Okay, mflops means millions of floating point operations per second. We can say mflops, gflops can be used also. Okay, and even tflops can be used also. These are millions. This is called the gigaflops. This is called the teraflops. Okay, million flops, gigaflops and teraflops. Those were the process speed of different types of computers. Now last concept I'm going to give you over here, just make a little room for it. What are multi-core processors? Multi-core processors. Multi-core processors, till recently, till now, the approach used for building the faster processor was to keep reducing the size of chips, okay, while increasing the number of transistors they contain. What I'm saying, that we were trying to keep reducing the size of chips while increasing the number of transistors they contain. Although this trend has driven computing industry for several years, this is the fact, it's now been realized that transistors cannot shrink forever. Transistors has a limit, so after that limit they can't shrink even more, so the processors can't be more efficient in the future. So they came up with a different technology. In this new architecture, a processor chip has multi-cooler running, more energy efficient processing cores instead of one increasingly powerful core. Okay, multiple cores are being used in place of only one powerful core. The multi-core chips do not necessarily run as fast as highest performing single core model, but they improve overall performance by handling more work in a parallel. That means before it we were using one single core chip. Okay, the instruction which were given to it, this was the sole responsible here to execute all the functionalities. So it has to wait for the first instruction to execute, and after that the second execution, after that the third execution, and so on. But what scientists did, they made parallel cores. Okay, one core, two core in just a single CPU. Okay, so what happens, they are virtually, so what happens, one instruction can be catered here, and the other instruction will be executed in here, but at the same time. That means they are multi-core and they are simultaneously processing the same instruction, processing the different instructions but in the same time frame. Okay, so I hope you have understood about the processors. So far, I tried my level best to explain each and every part of the CPU, but still, if something is remaining, you may ping me in the comment box regarding that. And if you have any query regarding the this lecture and the processor, you can ask me in the comment section. So take care of yourself, and do please do like, share, subscribe, whatever you can do with this lecture, as many as people you can share it with. So I'll be happy if you support me for my future videos also. I will keep on uploading my future lectures as quick as possible. Till then, take care of your good self. Thank you very much.